session. Here we go. And I'll go ahead and get started. At any point in time, if you have any questions on any of the stuff that I'm doing, please let me know, and I'll be more than happy to answer any questions you might have. Okay, so don't feel like you're going to interrupt me. You're not. And I really want to make sure that the stuff is making sense as we're going through it. All righty. Okay, so I'm getting my pen going here. So 6.1 talks about these things called confidence intervals for the mean. And it says estimating population parameters. And it says in this section here, we're going to explore how we use sample statistics to estimate the value of a population parameter, in particular, the population mean, mu. So it says a point estimate is a single value estimate for a population parameter, and the most unbiased point estimate of the population mean mu is what we call the sample mean. So it says, let's take a look here. The data below represents a random sample of the number of hours worked by 30 employees from several grocery stores in a county. Find a point estimate of the population mean mu. Okay, so the first thing I'm going to do, I'm going to get my calculator going here. And again, my calculator works just like my app. And what I'm going to do is I'm going to enter all these numbers in here. Okay, so I'm going to stop sharing this so that you can see how I'm going to do this on my calculator. Good, Priscilla, you're too excellent. Good, I'm glad you all were able to make it. Sorry, guys, I had to do it a little bit earlier today. I'm testing in my other class today at 6:30, so that was the reason. But next week we'll be back.
No worries, we understand.
Okay, appreciate it, thank you. So let's see. So guys, all I'm doing is I'm going to enter those numbers that were on my, this is again for my 6.1 stuff. So first thing I'm going to do, I'm going to hit stat, and I'm going to go to edit. And okay, so my list is clear, and all I'm doing here, I'm just going to start entering the numbers in. So I had 26, and I'm just going from left to right. 25, 32. Sorry, it's going to take me a little bit of time, but just one quick second. 28, and we had another 28. We had another 28. We had a 22, another 28, and a 25, and a 21, and a 40, let's see, and a 32, and a 22, and a 25, 22, 26, 24, a 46, let's see, a 20, a 35, a 22. So guys, one thing I do want to mention as I'm going through these, entering my numbers in. So I've only been teaching stats a couple of years. This is like the end of the second year I've been teaching it. And the one thing I've always kind of told my students is, even though this part here gets a little tedious, you just want to be really careful, because if I enter in one of those numbers incorrectly, then obviously it's going to kind of throw my answers off, right? And a lot of times it's kind of tedious and stuff, but that's just how it turns out. Okay, so those are my 30 numbers. And so now the first thing I'm going to do from here is I'm going to come back and I'm going to hit my stat button again. I'm going to go to calculate, and I'm going to hit my one variable stats. And I think I can just hit enter here. Okay. So I'm coming up with a couple of things here. And the more important thing that I really want to do or look at from this portion is my X bar. Okay, so my X bar in this case ended up being a 28.23. So I'll probably just write it as 28.2. So let me stop sharing this and then come back and pull up the notes one more time. And so what we came up with was our X bar being something like 28.2. Okay, so when it says find a point estimate for the population mean mu, what they're telling me here is like we're trying to find an average of the number of hours worked by all employees at grocery stores. So what we did is we took 30 employees from different grocery stores in the county. Okay, so if we were like in Cameron County, we might pick an HEB in San Benito, and we might pick a Walmart in Brownsville, and we might even pick the little tiny grocery store in La Feria. You know, that's kind of the idea. And so they picked 30 employees, and then we found the average number of hours that those people worked. And we're saying that this here is what we would call our point estimate. This is kind of like our average based on these 30 employees. So, so the next part right here, I'm just going to start reading right here, and it says, in the previous example, the probability that the population mean is exactly your point estimate is virtually zero. So let me just explain what that sentence means, right? If I was, again, referring, say, to Cameron County, and we were to say, what's the average number of hours that all of the grocery store employees would have worked? What's the likelihood that that answer would have been 28.2? It probably would not be 28.2, right? We said the probability that it's exactly 28.2 is probably zero, right? Because you're going to have so many different employees working so many different hours. You might have somebody who's a full-time employee and maybe they work overtime. You might have somebody who is elderly and they just want to kind of do something to occupy time, so they work 10 hours a week, right? Anyway, okay, so the next part says we can say with a certain level of confidence that the population mean lies within a certain interval around our point estimate. So here it says the level of confidence is a probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. Okay, so what we have here, guys, is what we call our confidence intervals or our confidence values, okay? So we're looking at the area in between these particular values here, okay? And we call those values critical values. And the C is going to be the area under the standard normal curve between those values there, okay? And so I'm going to explain what is this 1/2 minus 1C. I'm going to explain that piece to you guys in a second, okay? So let's see if we can do this by coming up with an example. I'm going to leave the picture here so that you can kind of see what I'm referring to. So the directions for this problem here, and guys, I copied this problem directly from my math lab. I try to do that with a lot of the problems in our notes so that when you're going through your assignment, it's something hopefully that you've already seen. But it says, find the critical value ZC necessary to form a confidence interval at the level of confidence shown below. Okay, so what that means is I'm going to draw a picture here. Here's my standard normal curve. And I'm looking to find these values here. Now, I want to point something out. One of them is going to be negative. One of them is going to be positive because I know right in the middle is zero. And what we're saying is, since it's given me this C, 0.92, that's telling me that the area under this part of the curve in here is 0.92. Now, just a reminder that the total area under the curve is equal to 1. Okay, so if I wanted to figure out, well, how much area do I still have left here and here, I would say, well, let me take 1 minus 0.92, and that would give me 0.08. So I have 8% left to be divided amongst those two parts. And because my graph is symmetric, that means that I'm going to take this number here and I'm going to divide it by 2. So that's telling me the area right here, y'all, is 0.04. And the area right here is 0.04, okay? Because if I were to take these three numbers, and if I were to add them together, I'd come up with 1. So now what I want to do is I want to find what is this value going to be right here, okay? So the way I can do this is I can go, using my calculator, I can use the inverse norm feature, and I can say, well, I know that the area to the left is 0.04. So guys, just a quick reminder on my calculator, I'm going to go second, bars, inverse norm, and I'm going to type in the area to the left of that, which was 0.04. So let me do this part on my calculator so you can see what I'm talking about. And Perla, yes, ma'am, you have a question for me?
Yes, sir. You know how you inputted this 0.04 with the so how come it's not a negative if we're looking towards the left? How come it's not a negative
Okay,
0.6.
excellent. Yeah, excellent question. So remember, the z value that I'm going to come up with, Perla, is going to be a negative value. But remember, because I'm looking at the area underneath the entire curve is equal to. So let me do this real quick so you can see me. So the area underneath the entire curve is equal to 1, right? The area underneath that whole thing is equal to 1. And I'm trying to do this from your perspective. So this, from your perspective, this will be the negative side. This will be the positive side. So because I'm looking at those two parts, and I know that the area here in the middle is at 92%, that means that I have 8% to be divided among these two parts. So this is 4%, this is 4%. That's still the area under the curve. But you're right, I am going to get a negative value for my z-score. So I'm going to show you exactly what I mean by that. And I'm going to do that right here. Excellent question. I'm glad you asked that. And so let's see. So let me clear this out. We said we're going to go second and then vars. And we're going to scroll down to our inverse norm. And we're going to type in 0.04. And when I do that, look, there's our negative value, right? So my z is coming up with a negative value. It's a negative 1.75. So now let me show you what I'm going to do in terms of my picture. So I'm going to come back here. And excellent question. So we came up with this value here being a negative 1.75. So then this value is going to be a positive 1.75, okay? And I'll kind of just draw it again because I know we got a little bit messy there. So here we go. We said this area was 0.92, so we had a 0.04, 0.04. So negative 1.75 and 1.75. Okay, so now when I look at the directions here, and it says find the critical value ZC. Remember what I said, guys? We were going to have two of them, one of them being negative and one of them being positive. Since it's asking for ZC, my positive one is going to be 1.75 because it's asking for the positive one. Sometimes the way they write it like this. Z of 92 is 1.75 because my confidence interval was, I'm sorry, a 0.92. Okay. So excellent question. I hope that, did that answer it? I'm not sure if I answered it correctly.
I kind of understood since it's the whole complete, I guess, value of the entire curve is 1, the complete 1. So you cannot have a negative and a positive 1.75 to complete an entire whole number, which is 1.
That's right. So I want to remind you of something right here in the middle. Remember, my value right here in the middle, is, oh, come on, pen. My value right here in the middle is 0, right? So I know that any z value that I get on this side is going to be negative. And then I know that any z value that I get on this side is going to be positive. But the area is always going to be a positive number because the area refers to the probability, right? And so the probability, an easy way to think about probability is to think about, like, if Tim Smith says, hey, there's a 8% chance of rain tomorrow, or there's a 30% chance of rain tomorrow. Those values, whatever percent chance it is, it's always going to be either a positive number or it's going to be 0, right? If he says there's no chance of rain tomorrow, then my probability would be 0. But Tim Smith would say, hey, there's a negative % chance of rain tomorrow, right? They would never say that. So that's why my any values that I get in here are always going to be positive numbers, somewhere between 0 and 1, because the area under the entire thing is always going to add up to 1. So, excellent question. I think that was a really good question to ask. And so I'm going to zoom in a little bit here, guys. And it says, since my sample mean is going to vary from sample to sample, there's something we call a sampling error. And the sampling error is the difference between the sample mean X and the actual population mean mu, okay, which is typically unknown. However, we can calculate the maximum value of error when you know the level of confidence in the sampling distribution. Okay, so I got a little formula in this box here, and it says we have something called the margin of error. Sometimes we call that the maximum error of estimate, or the error tolerance, is the greatest possible distance between the point estimate and the value of the parameter is estimated. For a population mean mu, where sigma is known, the margin of error is given by, so here's my formula right here, okay? And it says, number one, there's a couple of conditions we have to have. Number one, the sample has to be random, and then my n, the number in my sample has to be 30 or more, okay? All right, so let's take a look here. And it says, use the data in problem number 1 and the 95% confidence level to find the margin of error for the mean number of hours worked by grocery store employees. And it says, assume the population standard deviation is 7.9 hours. Okay, so guys, first thing I'm going to do here, I'm going to deal with this 95% confidence level, okay? So first thing I'm going to do, I'm going to draw a picture, okay? So here's my picture. Just a reminder, my number here in the middle is always going to be 0, right? Since it's a 95% confidence level, I'm going to be looking for two values. Remember, this value here is going to be negative, and this value here is going to be positive, right? I know that since it's a 95% confidence level, that the area in the middle here is 0.95. So if I want to figure out how much area do I still have left, I'm going to go 1 minus 0.95. That gives me a 0.05. That 0.05 needs to be divided amongst those two portions. So if I take this and I divide it by 2, I'm coming up with 0.025. That's going to be the area under this piece, and that's going to be the area under that piece, okay? So now, the one way I can find my critical value, I can find this one, and then guys, remember, once I find this one, I already know that one is going to be the same thing, but without the negative, okay? So the way I'm going to do that portion is I'm going to go second, bars, and then I'm going to use my inverse norm. And remember, my inverse norm is going to help me find the z value when I know the area to the left, okay? So the area to the left, we said, was 0.025. So let me do that part on my calculator so you can see what I'm doing. Where are we? Here we go. And let's turn this part on. Here we go. Okay, so I'm going to go second, bars. I'm going to scroll down to my inverse norm. And we said we had a 0.025. And I'm coming up here, guys. Usually for the z values, we usually use 2 decimal places. So I'm coming up with a negative 1.96. So let me stop sharing this, and then I will come back to my notes. And I'm going to write down here, I know that this value, is a negative 1.96. So this one is a positive 1.96, right? Okay, so what we've done at this point, y'all, is we found our ZC value, okay? Now, the reason why I need that ZC value is I want you to look at my formula that I have up here, and I'm just going to rewrite it so I have a little bit more room. It says my error is equal to my ZC value times my standard deviation divided by the square root of my sample size, okay? So for this particular problem, what I'm going to do is I'm going to say, look, do we already know our ZC value? Yeah, we know that we just came up with that number. That was 1.96. Okay? And then the second thing is, do we know our population standard deviation? And they gave that to us too. They said that number was 7.9. So I'm going to put a 7.9 right here. And this is divided by the square root of n. Now remember what n was. N was the sample size. Since this problem says we're going to go back to problem number 1, I'm going to scroll back over here. And if I look at problem number 1, the number of employees we examined was 30. So that was just telling me here that my n was equal to 30, okay? So I'm going to scroll back down. Let me see if I can find this. It is right here. And I'm going to fix my parentheses so they look more like that. And I'm going to do this part on the calculator for you all the same way. So I'm going to stop sharing this portion, and I'm going to come back to my calculator so you can see. And guys, again, I'm using this one just because this is what's on this computer. Okay, so we had 1.96 times, and then I think I had parentheses, what was it, 7.9 divided by, and I want to get the square root button. So I'm going to go second. Right here above my x squared, you can see there's a little square root right there. So second, and then x squared, here's my square root, 30. Because this calculator opened up parentheses for my square root, I got to close those off. And because I opened up a set of parentheses here, I got to close those as well. And then I'm going to hit enter, and I'm going to go ahead and write down 2.83 because I'm going to round to 2 decimal places, okay? So 2.83, and let's see. Yes, Perla, you were asking if this is 6.1. Yes, it is 6.1. I'm sorry, I just saw your chat right here. So let's see. Come back over here, and we came up with our error to be 2.83, right? So my error was 2.83. All right. So, guys, before I go on to problem number 3, one thing I want to point out, the first thing we did was we were trying to find the critical value. And because we're trying to find that critical value, I have to use my confidence interval information. So what we did first is we said, well, let's draw this picture. And what does a 95% confidence interval mean? It just means that the area between whatever these values are is going to be 95%. So that means that there's 5% left to be divided amongst the two other parts, okay? And so we did the inverse norm feature. Now, one thing I want to point out, I'm going to kind of scroll back to the top here, okay, right here. There are certain standard levels of confidence, okay? So if the problem ever tells me, hey, can you the critical value for an 80%, a 90%, a 95%, or a 99% confidence intervals, they are right here. And I don't always have to draw that picture and figure things out, okay? The issue is, well, what happens if it's not an 80, 90, 95%, or 99? Then I go ahead and draw my picture. And if you notice, guys, for the problem that we did, we had a 95% confidence interval. And didn't we come up with 1.96 for our number? Because that's what we said we got right there, right? There was my confidence interval. There was my ZC value, right? So I can go back and look at that portion here. Time it's given me one of those kind of values. If it's given me anything like that, I can always do that, or I can use my calculator. Perla, ask me.
Yes, sir. For that table, do we have it in our book, or is it in our work?
Yes, it'll be in your book. It'll definitely be in your book. And then, guys, I'm going to show you something real quick. Like, let's see. So give me one quick second. I'm pulling up. Let's see. Okay, here we go. Okay. So let's see. Let's see. Let me find what I'm looking for. See if I can find it here. Yes. Okay. So I'm going to show you something right here. So let me stop sharing this, and I'm going to share with you guys. Let's see. Chrome tab. Here we go. So guys, this problem right here is number 5 in your homework. And I want you to notice something here. It says, find the margin of error. So this problem right here is almost identical to the one that we just got finished doing, okay? And it says, find the margin of error for the given values of C, sigma, and N. Okay, and then it says right here, click the icon to view a table of common critical values. So when I click on this, yeah, y'all can see that. Sorry, you can see that I have this one. When I do it here, is giving me 90, 95, and 99, right? So I can see that those values are there, right? So if I was going to do this problem, and I'll actually do it here for you guys so you can see what I'm referring to. I'm just going to write some things down. Let me get a pen here. C is 0.95. Sigma is 3.6 and N is 81. Okay, so let me stop sharing this portion and then let me share my notes. Okay, so what I'm going to do is I'm just going to kind of work over here on the side somewhere. And there was a couple of pieces of information that they gave us. They gave me that C was 0.95. They gave me sigma to be 3.6. And they gave me N to be 81. And they were asking us to find our margin of error. Okay, so guys, all I'm going to do is I'm just going to write down the formula that I had there in my notes. Okay, so if I were to come back and I were to say, okay, well, you know what? What's the critical value when I'm using a confidence interval of 0.95? And that's when we said we can use our, let me see, where is it? Here we go. We can use this portion right here. Since it was a 95%, we can use 1.96, right? So, sorry. So what I'm going to say here is, okay, well, this number is a 1.96, right? And then, let's see, my sigma was already given to me. This was a 3.6 divided by the square root. They already gave me my N value. This was an 81. And then, guys, I'm going to do this exactly on my calculator, just like I see it right here, okay? So let me stop sharing this portion for you, and let me share my calculator so you can see what I'm trying to do. Okay. All right, so let me clear this. We said we had a 1.96 times parentheses. My sigma was a 3.6 divided by, I'm going to go second square root of 81. Again, my calculator opens up parentheses, so I got to close them again. And then I'm going to hit enter. And the number that I'm coming up with is a 0.784. So what I'm going to do now is, let's see, here we go. Okay, so the directions for this problem said, go ahead and round it to 3 decimal places. So I'm going to type in 0.784 because that is 3 decimal places. I'm going to go chickadee check. And so we got it, right? And so, good question. I think this was a great, it was good to ask about those tables because you will see that as you're doing these problems, they are going to show up, right? And sometimes they show up and sometimes they don't. And if you notice, like for this one here, it's a 98%, right? So since the 98%, that's not one of those common values. So instead of me just doing this problem, let me go back to the notes so that we can get an understanding of how I kind of work through this here. Okay, so let's see, here we go. Okay, so number 3 says a survey of a random sample of 1,000 smart owners. Okay, so guys, the first thing I noticed, they're asking 1,000 smartphone owners. So that means that my N is 1,000. It says we found that the mean daily time spent on communicating on a smartphone was 131.41 minutes. So that's telling me that my X bar was 131.4. From previous studies, it is assumed that the population standard deviation is 21.2. Okay, so my population standard deviation is 21.2. This is in minutes. Now it says for a 90% confidence interval. Okay, so my C is equal to 0.90 because it's a 90%. What would the margin of error be for the population mean daily time spent on communicating on a smartphone? Okay, we're going to find our margin of error. So that formula again is ZC times sigma divided by the square root of N. Okay, so guys, first thing is, since they are giving me a critical value, a confidence interval of 90%, I believe if I scroll back up here, we should have one for 90. Yes, we do. So let me clear this so we can see it a little bit better. So for 90, my ZC value is going to be 1.645. Okay, so let me scroll back down here. Let's see. All right. So my ZC was 1.645. Okay. And then we said our sigma was at 21.2. and my n was 1,000, so this is over the square root of 1,000. And again, I won't show you this on the calculator because I think we've done it a few times, but I think you guys kind of have the hang on how to do this on your calculator. So I'm just going to do it here on mine, and I'm just going to type it out. 1.645 times parentheses 21.2 divided by the square root of 1,000. Closing, hit enter. And so what I came up with here was 1.103. 1.103. And the reason I went to 3 decimal places here was just like in the problem in the homework that we just did a minute ago. It said, go to 3 decimal places. So that's why I was doing that right there. Okay. Now, so the next 2 problems, guys, these problems, again, come directly out of your homework. And it says, use the values on the number line to find the sampling error. So before I do that, I'm going to come back over here. So I'm going to see if I can find it. Here we go. Okay, so if you notice right here, I'm going to highlight it for us. It says the sampling error associated with each sample mean. Okay, let me highlight this part. It says the sample error is the difference between the sample mean and the actual population mean mu. Okay, so sampling error, guys, is going to be x bar minus mu. Okay, so what I'm going to do is I'm going to scroll down here. Here we go. So sampling error is going to be equal to x bar minus mu. So here's my x bar number, 3.8. Here's my mu number, 4.19. So when I do this on my calculator, and I'm just going to do this real quick here. Here's my calculator, 3.8 minus 4.19. I'm coming up with a negative 0.39. So that's what I got for the first one, right? Okay. Now I'm going to do the second one. Sampling error equals x bar, minus mu. Okay, so look at my x bar now. My x bar is at 25.49. So I'm going to write 25.49 minus my mu is a 24.02. So when I subtract those, 25.49 minus 24.02, I'm coming up with a positive 1.47. Okay. So the idea here, guys, when we're looking for the sampling error, what we're saying is how close is my sample mean to my population mean? Since my sample mean here happened to be smaller than the actual population mean, since it was less than, my sampling error ended up being negative. We were too low, right? And then in this problem, since our sample, in the second problem, since my sample mean here was higher than my population mean, all that means is we kind of have like an overestimate, and that's why we came up with a positive value for my sampling error, okay? Yes, let's see, I think somebody's got a question, so coming back. Yes, ma'am.
So here on the line, you know how there's the first line has the x first, and then the second line is the mean or the u first. So is that what we're talking about? How they do the switch? One is going to give you a less value, and
That's
if they
right.
switch, one is going to give you a bigger value.
That's right. So if you notice, remember what I'm doing here is I'm trying to find how far is this number away from this one. And so if you notice, this one here was to the left of this number, right? So that means I underestimated. And because we were too low, because we were lower, we came up with a negative value, right? And this one over here, the population mean was higher. I'm sorry, the sample mean here was actually higher than the population mean. So it was kind of an overestimate, and that's why that value happens to be positive, right? But the idea is you're always going to use this formula. You're always going to take x bar minus mu. And if it ends up being negative, then it's negative. And if it ends up being positive, then it's positive. But that's always going to be my formula. I'm always going to do it like that every time, okay? So excellent questions, very good. So let's take a look, guys. Let's see if we can do number 4. So we're going to now talk about something that we call confidence intervals. And it says a confidence interval for the population mean mu is given by, so they give me this formula right here, okay? And it says x bar minus the error, and then x bar, this one here should be a plus. I don't know why it came out that way, but that should be a plus right there. I'll put in a plus here for you. Okay, and then here's my formula for my margin of error, right? Just like the formula we've been using before. All right, so number 4 here says we're going to construct a 95% confidence interval for the mean number of hours worked by grocery store employees from problem number 1. And then it says interpret our results. And it says there's a 95% interval that contains the population mu. All right, so we're going to construct a 95% confidence interval. So again, just a heads up of what that means. We're going to look for our critical values here. One will be negative, one will be positive, so that we know that the area in that part of the curve is 95%. So guys, because 95% is one of those common values, my ZC, so for 95 was, I'm going to go back and scroll again because I know it's right here. For 95 was, oops, there we go, 1.96, right? So I already know that that's my ZC value. So let me come back here. Okay, so my critical value was 1.96. Okay, so now the next thing I'm going to do, I'm going to go ahead and find my margin of error. The way I'm going to find my margin of error, I'm going to use this formula. Okay, and so we have 1.96 times, we set our sigma because we're going to problem number 1. Problem number 1 was the one about the grocery store employees. And guys, I want to say that if I scroll up to part 2, it gave me the population standard deviation as 7.9, right? So let me come back here. Okay. So we already knew that our population standard deviation was 7.9, and we knew from the first problem that we had 30 employees. Okay. So I'm going to go 7.9 divided by the square root of 30. And I'll go ahead and go to, let me do this part here on my calculator. So, let's see, 1.96, oops, 1.96 times parentheses, and we said 7.9 divided by second square root of 30, close it, close it. And we came up with something like 2.83, okay? So 2.83. All right, since we're trying to find what we call a confidence interval, this part right here, that's a plus, this part right here tells me how to find that confidence interval, okay? So my confidence interval is going to be x bar minus the error, and my population average is going to be somewhere between there and x bar plus my error. So for this particular problem, we already knew from part number 1 that our x bar was something like 28 point something. Let me come back and look because I forgot what number we got when we did problem number 1. 28.2, right? We came up with that number right there. Okay. Here we go. So my x bar from this problem was 28.2. So now I'm just going to fill in the blanks. I'm going to write 28.2 minus 2.80 or 2.83 and then 28.2 plus 2.83. So I'm going to do this portion here in my calculator. 28.2 minus 2.83 is 25.37, and then 28.2 plus 2.83 is 31.03. Oops, 0.03. So what we're saying is that our population mean is going to be somewhere between those two numbers. Within, we can say what the way my math lab will ask you is, we can say with 95% confidence level. The reason why 95% was because we used a 95% confidence level, right? So we can say with a 95% confidence level that the population average is going to be somewhere between those two numbers, between 25.37 and somewhere between 31.03. Okay, and that's the process on how we, that's the process on how we find confidence intervals. Okay, so number 5, we're going to do the same thing on number 5, but we're going to refer back to problem number 3, and it says interpret your results. Okay, so first thing is we're going to construct a 95% confidence interval. The mean daily time spent on communicating from on cell phones from problem number 3. Okay, so my confidence level here is 90%. So I'm going to have to find my ZC. In problem number 3, let me scroll back to problem number 3 if I can find it. Here we go. We knew that our N was 1,000, my X bar was 131.4, and my sigma was 21.2. So I'm going to write those numbers down so that I don't forget them. N is 1,000, X bar is 131.4, and sigma is 21.2. Okay, so let me scroll back here. Here we go. Okay, so N is 1,000. My X bar is 131.4, and my sigma is 21.2. Okay, so guys, I'm going to do this portion for us on the calculator, and I'm going to show you, I'm going to walk you through the steps on how I'm going to do this so that I don't actually have to go through the actual calculation of it, okay? So let me stop sharing this portion, and let me come back to my calculator so you can see what I'm doing. Okay, so let's go here. Let me clear this. So guys, what I'm going to do is I'm going to hit stat, and I'm going to go over to where it says tests, okay? And what I'm looking for is something called a Z interval test, right? Let me make sure. Yes, the Z interval right here. So I'm going to enter that in. And what I want to do is I want to go to stats. So I'm going to click my right arrow, and I'm going to hit enter. Okay, and let's see. I'm going to put some information here. So my sigma that we had for this problem, I believe, was a 21.2. And my X bar for this particular problem was a 131.4. Okay. And my N for this problem happened to be 1,000. So I'm going to type in 1,000. Okay. And then my confidence interval, I want to say that we were looking at a 90% confidence interval. So right here, I'm going to type in 0.90. Okay. Then I'm going to go ahead and go to calculate. I'm going to hit enter. And I'm coming up with a couple of numbers here. So I'm coming up with something like 130.3, or yeah, 130.3 and 132.5. Okay. So let me stop sharing this portion here. Let me come back to my notes. Here we go. And so doing that on the calculator, we can find our confidence interval saying 130.3 and 132.5. And so we're able to find that our population average is going to be somewhere between those two numbers, and we can say that with a 90% level of confidence, okay? So guys, to show you that this little process on my calculator works, what I want to do is, for the problem for number 4, look at the answers that we came up with. We came up with, when we did this by hand, we came up with 25.37 and 31.03. So what I want to do is I want to redo problem number 4, but I want to redo it using my calculator because I want to show you that either way, I'm still going to get the same answer, okay? So the only thing I need from this problem is my 28.2, my 7.9, my 30, and the fact that this is a 95% confidence level. Okay, so, and I should still come up with 25.37 and 31.03. So let's see, let's come back one more time. Let me get my calculator right here. Okay, so I'm going to go stat. Well, let me clear this out first. Okay, so I'm going to go ahead and hit the button stat. I'm going to go over it says tests. And I'm going to scroll down until I see the one that says Z interval. Okay, and I want to use the stats portion. Okay, so for this particular problem, we said that our sigma was a 7.9. Okay. And we said that our X bar was a 28.2, and our N happened to be a 30, and then my confidence level happened to be a 0.95, and then I'm going to go ahead and go to calculate, and I'm coming up with 25.373 and 31.027. So if I were to take those numbers and I were to round them to 2 decimal places, I would come up with 25.37 and 31.03. And if I stop sharing this and I come back to my notes, 25.37 and 31.03, and we came up with the same exact answer. So the reason why I showed you guys, let me see if I can do this. The reason why I show you all this process is not to try to make life hard, but just so that we have an understanding of what it is we're actually doing. But the calculator will do a lot of that computation for me, so that and think about what was I doing here. I'm sorry, on this part right here, what we're doing, we're subtracting 2 numbers and we're adding 2 numbers, right? And you look, this part here, we could find that using that little table. These numbers were already given to me, so I multiplied a couple of numbers and then I subtracted and I added. So it wasn't like I did a ton of calculations, but it can seem overwhelming at times. But I want to point out that the calculator will do a lot of this computation type stuff for me, okay? So look, let's do number 6, and again, we'll do it the same exact way, and then, let's see. Let me see, I'm trying to see if number 7 is the same type of problem. Or actually, you know what? Let's skip 6 and let's do 7 because I want to see if I can get at least to showing you how to do these next 2 parts, okay? Because number 6, guys, is pretty much the same way. All right, so number 7 says, the college admissions director wishes to estimate the mean age of all students currently enrolled in a random sample of 20 students. Okay, so I'm going to stop right here. What that's telling me, my N is 20. It says the mean age is found to be 22.9. So my X bar is 22.9. And it says from past studies, the standard deviation is known to be 1.5 years. Okay, my sigma is 1.5. Now it says construct a 90% confidence interval for the population mean age. Okay, I'm going to do this portion here, and I'm going to do it on my calculator. So let me stop sharing this, and let me come back to my calculator. Okay. All right. Okay, so let me clear my screen. And again, guys, so what I'm going to do here is I'm going to go to stat. I'm going to scroll over to tests, and I'm going to come down to where it says Z interval. Okay, I'm going to hit enter. I'm still going to use my stats information. So our sigma for this case ended up being 1.5. My X bar was 22.9. My N, in this case, was 20. And we said our confidence level, C, was a 0.90. And I'm going to calculate it. And my interval is telling me 22.348 and 23.452. So I'm going to write that down. 22.348 and 23.452. 23.452. So if I come back to my notes, there we go. Okay, here's my confidence interval, right? So guys, I'm going to write, before I go on to number 8 or the next portion, I'm just going to write this out kind of like the using inequalities, okay? So 22.348 is less than my population mean, which is smaller than 23.452. Again, this stands for my population mean, right? So what I'm saying is that with a 95% confidence level, that the population mean is going to be somewhere between those numbers right there, okay? It's going to be somewhere between those numbers right there. All right. Okay, so let's see. For this problem here, it says use the confidence interval to find the margin of error and the sample mean. Okay, so when I'm looking at this part right here, here's my sample mean, and my margin of error, or my values are 0.422 and 0.580. Okay, so what we're trying to do is we're trying to find the sample of error, and the margin of error and the sample mean. So guys, if I'm trying to figure out what is this number right here going to be? Notice that number is directly in the middle, right? I know that my population mean is going to be somewhere on this line, somewhere along here. I just don't know exactly what it's going to be. But my sample mean is always directly in the middle. So if I want to find what number is in the middle between these two guys, what I'm going to do is I'm going to take those two numbers. We're going to add them up and divide by 2. So if I take my calculator, 0.422 plus 0.580, I'm coming up with something like 1.002. Now I need to take that number and cut it in half. So this number right here is a 0.501. So we have found our sample mean to be 0.501. Now, that's this portion. Now, we still need to find what is our margin of error. What the margin of error is, guys, is what is the distance from here to here, or what is the distance from there to there? It's going to be the same number, okay, because that X bar happened to be in the middle. So if I want to find that margin of error, one way I can do it is I can take 0.580 and we can subtract 0.501, and we're going to come up with 0.079. Or we could have said, let's subtract this number minus that one. We'd end up with the same thing in either case, okay? And so we're able to find our margin of error, and we're able to find our sample mean. Again, guys, this is a problem that you have directly in your homework, okay? All righty. So now, the last portion here, and it looks like we're going to have time just to do this one here, guys, and then we'll have to call it quits there. But one thing I want to emphasize, 6.2 and 6.3 are almost identical to what we've been doing here, okay? So let's see. As the level of confidence increases, the confidence interval widens. As the confidence interval widens, the precision of the estimate decreases. One way to improve the precision of an estimate without decreasing the level of confidence is to increase the sample size. But how large a sample size is needed to guarantee a certain level of confidence for a given maximum error of estimate? Okay, excuse me. So it says, given a C confidence level and a margin of error E, the minimum sample size N needed to estimate the population mean mu is, and they give me a formula right here. Okay, so here's my formula in the middle of the page. We got it right there. And it says, if sigma is unknown, you can estimate it using the sample standard deviation, but in this case, we should have it. All right, so let's take a look here. It says, for the researcher for problem 1 wants to know the number of employees he must include in the sample to be 95% confident, that the sample mean is within 2 hours of the population. Okay, so first thing I'm going to do, I'm going to write down my formula. ZC sigma over E, all this being squared. Since my C value here is a 0.95, then we said our ZC happened to be a 1.96, okay? And then also, from problem number 1, I want to say that we said our standard deviation happened to be 7.9. And the error, okay, if it says the sample mean is within 2 hours of the population mean, then my error, guys, is going to be the number 2. Okay, so all I'm going to do now is just fill in my blanks. So our ZC value, 1.96, times my standard deviation was a 7.9. This is divided by 2, and this is all squared. So I'm going to stop sharing this so I can pull up my calculator and you can see it. Okay, so on my calculator, let me turn it on, let me clear this. So I'm going to go parentheses, because that's what I have, 1.96 times 7.9 divided by 2, close my parentheses off, and then we're going to square it. So here's my square button, and I'm going to hit enter, and I'm coming up with like 59.94 if I go to 2 decimal places. 59.94, okay? So we'll explain what that means. Here we go. So we said N was 59.94. Now, I want you to realize what the N stands for, right? The N stands for the number of employees. Well, we can't ask 59.94 employees, so we're going to have to ask 60, okay? And then that would be my final answer, okay? So, I'm sorry, I was hoping to see if we could do a little bit of 6.2, but 6.2, guys, very, very similar, okay? And you'll kind of see that as you're going through here. There's a couple of different calculations, but the process is still going to sort of be the same, okay? And at any point in time, guys, if you have questions, please don't hesitate to ask me. You know that I'll be happy to send you something, whether it's a little video or whatever.